Concavity. If f of x equals 3x to the fifth plus 20x cubed, for which interval or intervals is f of x concave up? Okay, so first derivative is slope, second derivative is concavity. So we'll start by writing out what we got here. Let's say f of x, it's a little high for my tastes. F of x equals, zoom out so I can see what we got going on here, 3x to the fifth plus 20x cubed. Okay? And then we'll take the derivative of such. Zoom in. There we go. Perfect. F prime of x equals 15x to the fourth plus 60x squared. F double prime of x equals 60x cubed plus 120x. And we want to find out where this is greater than 0 because we're looking for concave up. So I'm going to simplify this a little bit. I'm going to say 60 times x times, what's left over? X squared plus 2 greater than 0. And we want to know for which values here of x, this will be greater than 0. So this kind of gets down to algebra, and it's pretty easy to mess this up. It's easier just to look at this logically and try and think your way through it in a makes sense sort of way. So 60, always greater than 0. X squared plus 2, always greater than 0 as well. So this will always be positive, because if you take a number and square it, it'll be positive. Real numbers and such. So x squared is positive, 2 is positive. When their positives combine, still positive. So the only thing that will get flaky here is x. And x will be greater than 0 when x is greater than 0. So this entire equation here will be greater than 0 when x is greater than 0. That's it. Nothing more subtle, just that. And so the second derivative of x will be greater than 0 when x is greater than 0. And so this will be greater than, this will be concave up. This equation fx will be concave up from 0 to infinity, non-inclusive. And, interesting. That makes sense too, because when x is 0, it'll be 0, which won't be concave up. It'll just be no concavity. Inflection point? Probably inflection point. Okay, so that's the idea of finding concavity on an interval.